Hi everyone, this lesson is for geometry. This is a get your head in the game, last minute look at chapter 4 test. So let's get started. So for this little short warm up, what we're gonna do is I'm just gonna cover a few things for 10 minutes and hopefully that'll get your head in the game, right? All right, first kind of question that you're gonna see similar to this on the test is MNPQ, so MNPQ and RSTU, that should be RSTU, are similar. Find the values of X and Y. What is the scale factor and what is the ratio of perimeters? So for you guys, you need to redraw this shape as soon as possible. This is super, super important to redraw them, and you redraw them based on what is given in the directions. Like, how did they ask you to write? How did they write it? That's how you rewrite it. So for me, if I start here at M and I go N, right, then P, and then Q, and I end here at Q, all right? And I just I like to put arrows. So M to N, N to P, and then P to Q. So for me, I'm not even gonna look at this second shape. Right off the bat, I'm gonna redraw something very similar to this shape, and I'm gonna bring it down like this, go over, and then come back up, and then I'm gonna relabel it. I'm still not looking at this. And if this started with M in the left corner, then I'm going to write R here, then S, then T, and then U. Okay, it's very important that you redraw it just like that. So then once you've redrawn this, so if you went M, then N, down P, over Q, this goes R, S, T, and then U. This you've got to fill in the values now. So RS is 30, so you put that in. ST is 25, you put that in. R is 115 and TU is Y. And do we have all the values? We do. Okay, so now we can look at this and then we just basically solve the problem. We got to find X and Y, but we are not looking at this at all. We are done with that, okay? Don't look at it because that's just going to confuse you with the two shapes, okay? Redrawn, done. Find the values of X, and what's my scale factor? So my scale factor is going to be side to side. So it's not going to be X to 25 because I don't have X. It's not going to be 15 to Y because I don't have Y. It's going to be 18 to 30. And then reduce that. Let's start reducing by 3. 18 divided by 3 is 6. 30 divided by 3 is 10. I can still reduce that, right? Now let's reduce by 2. Divide by 2, 6 divided by 2 is 3, 10 divided by 2 is 5. So my scale factor is equal to 3/5 right off the bat. Now, similarly, good word, similarly, now that I've got my scale factor, I can find all the other values. So if I want to find X, right, I'm going to go X is to 25, and my sides are already lined up because I redrew the shape already. So we're going to go X is to 25 as 3 is to 5. We're going to cross multiply. So 5X equals 25 times 3. I'm going to divide by 5. X equals, and if I divide by 5, I'm going to get 5 times 3, and that's 15. So we've got X. Check. Now we want to find Y. Y is down here. So we're going to go 15 is to Y. I need more room. So 15 is to Y as, and now I'm going to use my scale factor again. 3 is to 5. I'm going to cross multiply. I get 3Y is equal to 5 times 15. And then divide both sides by 3. Y's cancel. Y is going to equal, 3 goes into 15. 5 times 5 times 5, 25. And there's my second answer. The last question says, what's the ratio of the perimeters? It's going to be the same thing as my scale factor. My scale factor is 3/5. That means my ratio of perimeter is also 3/5. If I was asking for the ratio of areas, we would take this value and square it, which would make 9/25. Next question. There are actually a lot of questions on the test on just this one topic. There are 3 ways to determine if 2 triangles are similar. That's it. The first way is angle. That's given 2 angles, okay? And that's it, because if you have 2 angles, you automatically have the third angle. This one has 2 sides, right? And an angle in between. See the angle in between the 2 sides. The last one is 3 sides, all right? So 3 sides. That was two sides and one angle. All right. So the first example, angle, is obviously you've got an angle congruent to an angle. These are corresponding angles. And then you've got this angle congruent to this angle. In triangles, angles, you should write this down somewhere. Angles are always congruent. Angles are always congruent. Sides are proportional, but angles are always congruent. All right. And also, look, these two angles are congruent to those two angles there. Automatically, this is a yes, they're similar. All you need is two angles to make them similar. If your lines are parallel, the two triangles are going to be similar. Now, if you see something like this, right, you've got this angle here congruent to that angle there. Those are vertical angles. You also have this angle here congruent to this angle here. Those are alternate interior angles. Because I hope you're seeing what this is like if you were to extend this line like this. See, those lines are parallel, and then they're cut by that transversal, which gives me that angle congruent to that angle. Okay, that's why those two are congruent. You just need two angles. I've got two angles. This is a yes. That is definitely a yes. These two triangles are similar. They're similar, and they're similar by angle. For this one, I do have this angle congruent to this angle. However, this angle, and this angle are all different. That means that these are not parallel. So this is definitely a no, because the two triangles don't have enough angles. Now notice, there are no sides. I did not give you any sides. You do not need sides to show that two triangles are similar. You just need two angles. For this one, see this angle here? That I've got two little curves and then two curves here. One curve here, one curve here. This is a yes. The two triangles are similar, and they're similar by angle similarity. Two angles works. The second option is when you have side, angle, side. So for this option, what you have to do is number one, and you should write this down. Number one, the one angle has to be congruent. One angle. So here I see that angle is congruent to that angle. That's one angle congruent. Done. Now, also, you need two sides. Not congruent. You need two sides proportional. And then what that means is by the way, those two sides have to be cupping that angle that's inside. So that angle has to be in between the two sides. Now, if I have one angle in between that's congruent, you cannot just automatically say these two triangles are similar, because you have to show the sides are proportional, okay? So now just pick a smaller side. This is 9. Which one of these is smaller? 21. Okay, so then if they are proportional, then I should be able to go 9 is to 21 as, this would be the other side, the bigger side, right? 18 compares to that side, 42. And if they are proportional, then I'm going to cross multiply. I'm going to get equal values. So we're going to go 9 times 42 is 378. And does that equal 21 times 18? 378. So what that means is this is a yes. These two triangles are similar by side, angle, side similarity. Now look at this. Those are not, oh, that's 3 sides. This is the wrong one. Sorry about that. This is not, this is a side, which we'll get to on the next page. Let's look at this bottom one. You have an angle that's congruent because of the angle inside here. Let me make this bigger. All right. You have this angle in the middle because these two angles are vertical angles. So I've got my angle in between my two sides. But not only do they have to be one angle congruent, check, but you have to have the sides proportional. So let's do this. So this side here goes with the smaller side. So 8 would go to 28. So 8 is to 28. Wait, actually, that's not right. Hold on. Let me fix this because I got to look at the way this is set. They didn't give me the actual triangle. So let me write this down. V, go up LM. So I'm going to go VLM. And I have to write this the same way because you have to Otherwise, you're going to get turned around like I almost was. So redraw it, so important. V has to be here, right? They have to be lined up. So V would be here. That means that U would go down here, and then T would be here. So VU is 28, and TV, this one is 49. Okay. So now we're going to compare the sides. So we would go 8 is to 28. Okay, so I was right. 8 is to 28 as 8 is to 28 as 14 is to 49. And so if they are proportional, I have to be able to cross multiply and make them equal. So we're going to go 8 times 49, and that makes 392. So that's 392. Does that equal 28 times 14? 392. So yes. So if these two triangles are similar, then the sides are proportional. So this is also a yes, and it's a yes by side, angle, side. Similarity. Check. All right. This one is 3 sides. You do not need any angles to show that these two triangles are congruent or similar. All right. So what happens though is that I have to redraw this. Even this one is easy because they're both in the same like direction, but this one is not. So I'm going to do, this is A, C, B. I'm going to redraw this little one because it's got to be in the same direction as the first one. Okay, so we go A. The A is the point. So see, this is the E. E's got to be the point, okay? And then it looks like going to the left, 14 is the smaller side. So that means this right here would be the smaller value. So that's going to be D down here, which means that has to be F. EF is 15, and then FD is 20. So now I'm going to cross this out because I do not want to see that because I redrew it. So now for these two triangles to be similar, then what has to happen is this. And I know this side, I know this is a little bit smaller. I don't know if I can make that smaller, but for these two triangles to be similar, all 3 sides have to be proportional. So we got to do all 3 sides. So we're going to go 14 is to 10. 14 is to 10 as 21 is to 15. So let's do that first, because if I get one that doesn't work, I'm done. So 14 times 15 is 210. So I've got 210. Does that equal 21 times 10? Yes, 21 times 10 is 2. Okay, so far so good. Now we're going to do the other side. I'm going to go 21 is to 15. So 21 is to 15 as, let's do 28 is to 20. As 28 is to 20. So I'm going to cross multiply. So 21 times 20 is equal to 420. 15 times 28 equals 420. Also congruent. So therefore, these two triangles are similar. So this would be a yes, similarity. Okay. For this one, obviously these are similar, but these 7 is to 7, 10 is to 10, 12 is to 12. These two triangles are actually congruent. Okay. All right. So for this problem here, I've got Logan. Logan is cleaning the barn, and he looks outside. So there he is. This is you, Logan. He looks up at an angle of elevation. So the angle of elevation that he's looking up is this angle right here. And he looks up and sees a bird at the top of the tree. What's the angle of elevation? Let's just call it 20 degrees, okay? I know I missed that value, so we'll put it 20 in there. Then he looks down at an angle of depression, also left that out. Let's say that angle is 42 degrees. We'll just say that's 42 degrees. The angle of depression, remember, goes straight down. That's based on a horizontal. Also, angle of elevation goes up, angle of depression goes down, both off of a horizontal. He is 50 feet away from the tree. So this is 50 feet right here, 50. So what we're asking is, how high is this tree? So we want this length right here, which means that we have to do 2 tangent problems in order to get that, okay? So the first one right here, this one, all right, this is 20, this is 50. We want to find that value, okay? So we're going to go tangent of 20 degrees is equal to x over 50, we're going to cross multiply. We get x equals 50 times tangent of 20 degrees. So on your calculator, go tangent of 20 degrees equals, it's like 0.36 something. And then you're going to take that and go times 50, and I get about 18.2. So x is about 18.2. So this value, 18.2. Now I got to do the bottom one like this, okay? And this is 42. And we're trying to find this value. Let's call it y. We also know that's 50. You're here. And we're going to go tangent of 42 is equal to opposite over adjacent. So I'm going to cross multiply on that. I'm going to get y is equal to 50 times tangent of 42. And so tangent of 42 is about 0.9. And I'm going to multiply that by 50. And I'm going to get 45. So y is approximately 45. So that's 18.2. This is 45. So we're going to go 45 plus 18.2, and I get 63.2. So the measure of the tree is tall at 63.2. The height of the lighthouse is 175 feet. So that means that up, straight up, like this, straight up, not on the side, but straight up, right, is 175 feet. Find the angle of elevation. They want this value, because remember, angle of elevation is from up. They also, though, gave me this. I don't know if you can see that. I'm going to write it bigger. That's 40 meters. So we know, and actually, let's stay with the same. We're going to make this 175 meters. And we're going to say this is 40 meters, so we don't have to worry about changing the unit measure. Okay, so you're looking up at the lighthouse, and you want this angle right here. So you're going to say tangent of theta is equal to opposite, which is 175, over adjacent, which is 40. Now remember, I'm trying to find the angle of elevation. So that means that I need to isolate the angle. So tangent's going to go to the other side. We have theta equals arc tangent, right? When you move it over, I'm writing inverse tangent, but we don't ever say that. That's improper. You say arc tangent, and then it's going to be 175 over 40. And so on your calculator, please go to arc tangent. Please make sure that you are in degrees also. 175 divided by 40, close the parentheses, I get about 77. So theta is about 77 degrees. That's the angle of elevation. Last problem. Given that theta is equal to 15 degrees, find the y coordinate of the point. So remember, put yourself here, right? This is you. And we are trying to find the y coordinate, which, remember, is the rise. Okay, so that's the y. Remember, you can go over x, up y. So over x is over 9, and then up y, which is we don't know. That's what we're trying to find out. So we're going to put ourselves here, and we're going to use tangent. Everything is tangent on this test. That's it. So tangent of the degree. What's the degree? The degree is 15. So tangent of the degree, 1/5, is equal to the opposite side over the adjacent side. And again, some people call it not opposite over adjacent, but they call it rise over run. Okay, so we are going to cross multiply once we have our actual equation. I'm going to cross multiply, get 1 times y is y. 9 times tangent of 15 is, I don't know, let's see, tangent of 15 is 0.26. I'm going to multiply that value by 9, and I get about 2.4. And so that means that y is about 2.4. So that means that my actual point is 9, 2.4. And then that's it for that. So, hey, good luck on your exam. You got your head in the game. Very proud of you. Good luck. Kick some butt here. All right. Thanks for watching.